Welcome to Electronics Techie. Today our topic is about laws of Boolean Algebra. In previous video we discussed about 4 laws. In this video we discuss another one, that is associative law. So just look into the associative law. What is associative law? Associative law in Boolean algebra states that the grouping of variables does not affect the result of operation. Means whatever the inputs you take, you have to combine it by any operation like AND operation or operation. You can combine the different variables, but the result will be the same. We can't change the result. The result, what will be the result? You can combine either 3 variables or 2 variables. The result does not change if you add from left to right or right to left, whatever the process, but the result will be not affected. This law applies to both AND and OR operations. This law is applicable to both operations. What are those? AND and OR operations. So in this associative law there are two parts. One is associative law of OR. OR means we know that OR is nothing but addition operation, and the second one is associative law of AND. AND is nothing but multiplication operation. We are represented with the symbols like that. So just look into these two into deeply and with some examples. And here we have to observe that associative law of R. R operation, you know that it is addition. So A plus of B plus C equal to A plus B of plus C. And what it means? It means that whatever the variables you take what 3 variables. Here we take A, one is a variable, and B is one variable, and C is one variable. We can doing OR operation. What is the addition? Addition is nothing but OR operation. You can perform the OR operation between these three. It doesn't matter how they are grouped. You can add A plus of B plus C or A plus B of plus C. It doesn't matter how you combine like this. Whatever the process you can done. Other you can add and you can do whatever the process, but the result will be not affected. It will be same. So let us consider one example. A is equal to 0, B is equal to 1, and C is equal to 1. So let's put these values into this equation, and A is equal to 0. You can combine. Here we can write this A plus of B plus C. Here can substitute these 0, 1, 1, 1 into this A plus of B plus C and A plus B of plus C. So the result will be the same. Here we observe that 1, 1. The result will be the same. 0 of, we know that 1 plus 1 is nothing but 1. So 0 plus 1 is equal to 1. So here the result is same. And whereas here we can observe that A is nothing but 0 plus 1, B is 1, and plus C is 1. So 0 plus 1 is nothing but 1, 1 plus 1 is nothing but 1. So the result will be 1. So whatever the performance, whatever the OR operation you can combine the inputs in different ways, but the output will be the same. So associative law is applicable to this OR operation. So I have to show you a truth table for you. So here is the truth table for this or associative law for R. So ABC are the 3 inputs, and what are the different combinations you can see that combinations are A plus B plus C equal to A plus of B plus C. Whatever the process, whatever the combinations you can take, the result will be the same. Here is the truth table for this. We can say take A, B, C as the 0 values, and you can substitute those values in here. So you get the result here. So finally you can observe that here and here the values are the same. If you have any doubts, you can comment. But you can substitute these ABC values in here, these equations. So final result will be the equal. Means the associative law is applicable for the OR operation. So it is the logic diagrams. Means first we have A plus B. A plus B is nothing but OR operation. OR operation means, so that's why you use OR gate here. And these A plus B is combined with C. So that's why you can use another OR gates, and another input will be C. So the output result will be A plus B of C. And another equation is of A plus of B plus C. So first we have to take to this B and C are the inputs of this is the OR operation. So you have to draw the OR gate. So another we can combine A with to these results. So you can, this result is B plus C. So this result is combined with OR operation of A. So you can, logic gates are seems like this. So just look into the next method like that. Second one is associative law of AND. AND operation is nothing but multiplication operation. We all know it is a product. So you can represent it with dot symbol like that. So A dot of B into C equal to A into B of into C. Means whatever here also you can done the AND operation. So you can here also you can consider 3 variables A, B, C are the 3 variables. You can perform the AND operations in between them. So whatever the process, whatever the combinations you can take, either A into of B into C, or A B of into C, like that. You can take any combination, but the output grouping, the result will be the same. It doesn't change anything. So by this more understanding, you can consider one example: A is equal to 1 and B is equal to 1 and C is equal to 0. So substitute these A, B, C values in these equations. So just find whether you get the same value or not. A into of B into C. So A is nothing but 1 into B into C means 1 into 0. So 1 is same as here, and here 1 into 0 is equal to 0. So final the 1 is equal to 0 is 1 into 0 is equal to 0. So second equation is equal to A into B of C. That is, A means 1 into B means 1 of into C means 0. So these 1 into 1 is 1, 0. This is not decimal point number, it is a product symbol. You can represent these AND operation with dots, so that's why I write like this. So 1 into 0 is equal to 0. So final result for A into of B into C, AB of into C, both the results will be 0. So it satisfies the associative law for AND operation also. So this is the process for AND operations. Here also you can observe that truth table for this. So this is the truth table for associative law of AND operation. So ABC, they are the different inputs are there. So I can take 4. They are the 3 variables. 3 variables means you already know the formula is 2 power n, that is equal to 2 power 3 means 8. So by these 3 variables you get 8 combinations. For 8 combinations I draw the truth table here. So whatever the A into B of C and A of BC, so whatever the results will be here, you can observe that 0, 0, 0, 0, 1 and the 0, 0 and so on 1. So the result will be, the final result will be the same. What it mean? Whatever the combination you can take, but the result will be unaffected. So that's why associative law is describe this. And here also you observe that logic gates for this. So A into of B, A into B of C. So A into B, they are the two inputs. So dot is nothing but AND operation. So we can represent these with AND symbol. So these AB is again multiply with C. So that's why I use another AND gate. So AB of C. And another equation is A of BC. So BC are the two inputs. I can apply this AND gate. And this result is multiplied again with A. So I can again draw this with AND gate. So the final output will be the same. So whatever the combination is you can take for AND operation or operation, these associative law is applicable for those AND and OR operation. And thanks for watching. If any doubts you can comment. Thank you so much.